Okay, it has become clear that a lot of us are doing well with the algebra, but we're having a little difficulty and missing problems because we are unsure of working with our integers. We're making our mistakes with our adding and subtracting because we don't have our rules straight for the adding, subtracting, multiplying, and dividing. So we're going to go through those rules. You do have a half sheet that you're going to take some notes on, and then you're going to do some practice problems on the back. So let's go ahead and get started. Let's start by defining integer, and actually let's back up. Let's start by writing your name and your 2 class periods at the top of the page because you are turning this in today. And then let's start with defining our integers. So an integer is a member of the set of whole numbers and their opposites. So remember, whole numbers are 0, 1, 2, 3, dot, 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 and so on and so forth. And then we're also going to do their negatives, dot, dot, dot. Now, I say we're doing operations with integers, but actually the rules that we're doing, they work with rational numbers as well. They work with your fractions and your decimals and all of that other good stuff. So we're going to concentrate on them with integers, but the rules are the same for the other operations as well. Let's start with addition. Notice our addition, I've got 2 different boxes here. One for the same signs. Go ahead and let's circle that so that it stands out. If you are adding and the signs are the same, you are going to add, you are going to add and keep the sign. So here's what we mean by that. If I have just 9 plus 4, signs are the same, signs are both positive, I'm going to add them. 9 plus 4 is 13. Since they are both positive, it stays positive. Okay? Now, in the second example, negative 4 plus negative 7. So I'm adding, and my signs are the same. So I'm going to add, 7 plus 4 is 11, and keep the sign, negative 11. If you think about your algebra tiles there, that's 4 red tiles. We lay down 7 more red tiles. That's a total of 11 red tiles. So negative 11. So if our signs are the same, we add and keep the sign. Okay? If our signs are different, let's circle that so it stands out. If our signs are different, you are going to subtract and keep the sign of the larger. That's the key. So you're going to actually subtract and keep the sign of the larger. So let's look at a couple of examples here. 9 plus a negative 4. My signs are different. The 9 is positive, the 4 is negative. So I'm going to subtract. 9 minus 4 is 5. Since the 9 is larger, it will stay a positive 5. Okay? For negative 10 plus 7, the signs are different. The negative 10, positive 7. So I'm going to subtract. 10 minus 7 is 3. And since the 10 is bigger and it's negative, it's going to be negative 3. So again, for addition, 2 rules. If the signs are the same, you add and keep the sign. If the signs are different, you subtract and keep the sign of the larger. Okay, now for our subtraction property, for our subtraction rule rather, not property, for our subtraction rule, we are actually not going to learn rules for subtraction. What we're going to do is always change our subtraction into addition. So remember, subtraction by definition means to add the opposite. Now, some of you probably learned this as keep, change, change. Keep the first one the same, change it to addition, and then change the sign of the next term. Okay, so for example here, 7 minus 4, hopefully you know that's just 3, but I'm going to show it to you using adding the opposite. So I'm going to change this to 7 plus a negative 4. Now I go back to my addition rules. Signs are different, so I subtract and keep the sign of the larger. So 3. We knew that one though. All right, 15 minus 20. Again, we're going to change it so that it's 15 plus a negative 20. Now I'm adding, and my signs are different, so I'm going to subtract. 20 minus 15 is 5, and keep the sign of the larger. So again, I'm not memorizing subtraction rules. I am changing my subtraction to addition and changing the sign of the next term, because subtraction by definition means to add the opposite. So I'm changing to addition, changing the next sign. Okay, our next example, negative 6 minus 10. That's negative 6 plus a negative 10. In this case, my signs are the same, so I'm going to add and keep the sign. And then last but not least, 7 minus a negative 10. I'm going to change that to 7 plus a positive 10, so I don't need my parentheses there. Would have been okay to have them. And then that's just addition. I'm adding, signs are the same, so I'm going to add and keep the sign. Okay. Now, I typically do this step in my head. I don't write that out every single time. You can if it helps you, if you need to. If you're not getting them right every single time, you might want to do that. You could also just change it right here and make that plus a negative, plus a negative, plus a negative, and then here plus a positive. Right? So you could do that if you wanted to. I typically just look at it and say, for example, here, I think of it as a negative 6 and a negative 10. Signs are the same, so I add and keep the sign. Okay, so that's our adding and subtracting. The adding and subtracting is probably the harder two operations than multiplication and division. And I think what a lot of you are doing is confusing your multiplication and division rules with your addition and subtraction rules. It's two completely different things. So we need to make sure when we're saying two negatives equals a positive, that's if you're multiplying or dividing. That's not if you're adding or subtracting. So keep those rules straight. For multiplication and division, our rules are actually the same. And it just goes by the signs. If the signs are the same, your answer is positive. And if the signs are different, your answer is negative. So that's it. So on my two examples here, 4 times 3, both positive, so positive 12. Negative 8 divided by negative 2, both negative, so a positive 4. 8 divided by 2 is 4. Signs are the same, so it's positive. If your signs are different, in fact, let's come back and circle these the way we did the others. If your signs are different, you are going to multiply or divide, and your answer will be negative. So 5 times negative 2 is negative 10. Negative 6 divided by 3 is negative 2. So these are our rules for working with our integers. Again, your addition rule, if the signs are the same, you add and keep the sign. If your signs are different, you subtract and keep the sign of the larger. With subtraction, you are going to add the opposite. So you're always going to change it to addition. Otherwise, we'd have to memorize more rules, and we don't want to do that. We just change it to addition and change the sign of the next number. With multiplication and division, if your signs are the same, your answer is positive. If your signs are different, your answer is negative. All right, what I want you to do now, you're going to move onto the back side of this little half sheet, and on the back side are 12 practice problems. This should take you a couple of minutes. This should not take you a long time, but you are not using a calculator on these. So you need to be able to do these without a calculator. So think about what operation you're doing and use the appropriate rule. I will be checking these for correctness. So let's make sure you're really putting some thought in, and then go back and double check and make sure you didn't make any careless errors. We need to be able to work with our integers because they're not going anywhere. We want to make sure that if we know our algebra, we're not missing easy points because we added wrong. All right, good luck. Have fun.